Do you want to learn about number system, integers, rational numbers, irrational numbers, and whole number system? What are factors and multiples? How do we do prime factorization? And how do we find HCF and LCM using prime factorization? So this package will help you in every class. Okay. So let us start number scales. We will start with number system. Our module 1 is number system. Okay. We will start with types of numbers. So suppose I write the counting, basic counting. If you want to count something, you always start with 1, 2, 3, 4, like that. They come naturally from your mouth, right? This is how we count. So they are known as natural numbers. Natural numbers, right? So 1, 2, 3, 4. If I say 2.5, it won't come inside natural numbers. Natural numbers are just these numbers 1, 2, 3, 4, and up to so on. Okay. So if I add 0 in these numbers with 1, 2, 3, they are as it is up to so on infinity. They go up to infinity. Infinity means not defined. We don't know what is the last number. Okay, that is infinite. Okay, so if I add 0 as well in these numbers, then these numbers are known as whole numbers. What are these? Whole numbers. So first we have natural numbers and then we have whole numbers. Okay, so that means whole numbers are bigger than natural numbers. I will say these are smallest and then whole numbers are bigger than, they have just a one extra number and that is 0. Okay, and after that comes integers. What are integers? You know what, integers are also whole numbers only. Whole means a complete number. It is not a part. It is not 1 by 2, 2 by 3. It is not fraction. Okay, it is a whole complete number like 1, 2, 3. But when we have negative, -1, -2, -3, -4, and positive, and like 1, 2, 3, 4, okay, negative and positive and 0 as well, all these are integers. So if somebody asks you integers, so integers are bigger than what? Integers are bigger than whole numbers and natural numbers. So natural numbers were the smallest and then whole numbers because they had 0 as well, and now negatives and positive whole numbers are known as integers. Okay, after that, we have rational numbers. Rational numbers means fractions, right? Like 1 by 2, 2 by 3, something that can be written in the form of P by Q. You know what? You need to remember a condition here, that the denominator, this is called numerator, this is called denominator, right? N by D, numerator by denominator. You know what? In rational numbers, this denominator cannot be equal to 0, right? So if I say 2 by 0, this is not a rational number because this number does not exist. It is not defined, okay? Usually we say it infinite, but it is undefined number. Something by 0 is not defined, okay? So we have 2 by 3, 4 by 5, 7 by 8 or 8 by 7. All these numbers are called rational numbers which are in the form of P by Q, okay? They are called rationals. Now, what are irrational numbers? Irrational numbers, suppose now I am writing a number, a decimal. How? 2.34212578 9, and I'm not stopping. I will keep writing the numbers. It goes up to infinite. I don't know how where will it stop. Okay, these types of numbers are called irrational numbers. They cannot be written as P by Q. They cannot be written as P by Q. Okay. They cannot be written in the form of a fraction. These types of numbers are called irrational numbers. Okay. So what are real numbers? Now real numbers, this is a real line. Have you heard about it? This is a real line. I'm putting arrows here because it goes up to infinite, to positive infinity from here, to negative infinity from here. It goes up to infinite. Okay, here we have 0. Then on the right hand side we have positive numbers. Though I am writing only natural numbers here, but it doesn't mean that it has only natural numbers. It has like 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.01, 0. Like it has small decimals as well. It has fractions like 1 by 2 is here. Okay, 3 by 2 is here. So it has fractions and all those numbers, rationals, irrationals, all those numbers lie on these real line. So like all the numbers, whatever we have studied till now, what numbers we have studied? Natural numbers, right? So natural numbers are here, right? 1, 2, 3, 4, 5. Now real line is the biggest real line. Okay. So real numbers are the largest if I say in this form. So real numbers contains natural numbers and then whole numbers because 0 is also here. So whole numbers and then integers because negative and positive whole numbers are here. So integers and rational numbers. Irrational numbers, you know what, like under root 2, pi. These are irrational numbers. Under root 2 is 1.414 up to so on. It will keep going onwards. So this is an irrational number. Pi 3.1428 up to so on. It will keep going on. Okay. So these numbers are called irrational numbers. And irrational numbers also exist on real line. Root 2 also exists here 1.4, 1.414 something that exists here, somewhere here. Okay, though I can represent it. There is a method that you will learn in grade 9. Okay, but this is for beginners, so I will not show you how to represent it on number line, but usually it does. Okay, so this real line contains all the numbers: natural, whole, integers, rationals, irrationals, and the real numbers are the largest. Okay, so these are real numbers. After that, now we come to question. After every topic we will do questions as well to practice. Okay, so you can see whether you learned or not. Classify the following numbers as natural, whole, integers, rational or irrational, right? Minus 5. What is minus 5 now? Minus 5 is negative. Negative is negative whole number is what? Integer. So minus 5 is integer, right? 0. What is 0? 0 is a whole number as well. 0 is integer as well, right? 0 is an integer and 0 is whole number as well, right? 3 by 4, it is a rational number, right? This is an irrational number and this is 2.5. It's in decimal. It can be 2.5. If you remove decimal, you will get 25 by 10. That means if you simplify it, it is 5 by 2. That means it can be written as a fraction. So that means it is a rational number. Okay. So this is how we can classify, right? After that we have, which of the following are rational numbers? Express them in P by PQ form. Okay. So first we have 0.75. We will count how many digits we have after decimal. 2, right? So I will remove the decimal, and because we have 2 digits, so I will write 100 here, 2 zeros. Okay, then I will simplify with, I suppose I say 5, though we can simplify it with the 25, but I will first simplify with 5 and then 5 again. What did we get? 3 by 4. So 3 by 4, or this is 75%, this is 3/4. So 3 by 4, we represented it in the form of P by Q, right? Okay. Then we have under root 16. What is under root 16? Under root 16 is 4 square. Under root of 4 square. 16 is 4 square. Powers we will learn further, but still I can just tell you here that 4 square is 4 times 4. Okay, so 16 can be written as 4 square, and then under root of 4 square is 4. Square roots and squares like exponents we will learn further, but here just so you know that 4 square under root of 4 square is 4, and 4 can be written as 4 by 1. So this we represented in p by q form, right? Okay. Pi is an irrational number, 3.1428 irrational number. Okay. So 3.1428 and up to so on like that. Then minus 8 by minus 8 can be written as minus 8 by 1. If you have a whole number, you can represent it in the form of rational numbers as well, just by writing 1 in the denominator. Okay. So after that, now we have properties of numbers. You know what? Whenever we have numbers, certain properties we can apply on that number. Okay. We have like closure property as well, and then identity, other properties as well, but here we are gonna learn first commutative property. What is commutative property? Commutative property means like we are applying it on addition first and then multiplication. What does it want to say? It wants to say that if I add 2 and 5, I write 2 plus 5, that will always be equal to 5 plus 2, right? So that means addition is commutative. Okay. Likewise, multiply. Suppose I am multiplying two numbers. 3 times 5 will be equal to 5 times 3. So multiplication is also commutative, but it depends on set as well. Okay, whether the set is natural number, whether the set is rational numbers. Okay, so when we explain properties or when we learn properties, we first take a set and then we take operation and then we check whether it is commutative or not, whether it is uh, uh, commutative or not, and then closure property satisfy or not, it has identity or not, all those things. Okay. So here we have now associative property. What is associative property? For associative property we take three numbers. Okay. It says that suppose I am taking three numbers, 2, 5, or any number you can take. I took 2, 5, 7. Okay. So they say suppose I add 5 and 7 first and then I add 2. Okay. That means 2 plus 5 plus 7 is what? 12. What is the answer? 14. Now they say instead of adding 5 and 7 first, what do? I add 2 and 5 and then I will add 7. Will that affect? No. Answer will still be equal to 14. So this is known as associative property. It verifies in multiplication and in addition both. Okay. Whether you are adding numbers or you are multiplying, so it doesn't depend on the order of numbers. Okay. So whether you can add last two numbers first and then you add first number, or you can add first two numbers and then add last number. Okay. So this is what associative property. Okay. After that we have, this is little bit tricky, distributive property. Okay. What is distributive property? It says, suppose I will take an example. Okay. It is taking three numbers a, b and c. Okay. I will take three numbers 2, 5 and suppose I took 6. It says if I write 2 here, 2 multiply 5 plus 6. This is how we open brackets as well. When we learned algebra, I did algebra package, we learned this. So whatever we have outside the bracket, we will multiply that with every number inside. Okay. So 2 I will multiply with 5 plus, because if we have plus here, plus 2 I will multiply with 6. This is nothing but distributive property. Okay. That a, whatever is outside the bracket, that will be multiplied with b first and that will be multiplied with c. Okay. A plus a multiply b plus a multiply c. Okay. So 2 times 5 is 10. 2 times 6 is 12. It is 22. Okay. So this is how I multiplied. What if I do this? LHS is A times B plus 6. So 2 times, instead of 5, I will solve the bracket first. 5 plus 6 is 11. So 2 times 11 is 22. So you do it this way or this way, you will get the same answer. This is distributive property. Okay. So if you have any doubt, you can ask in comment section. I will try to answer all the doubts. Okay. After that, identify which property is shown. Okay. Here it is showing 5 plus 7 is equal to 7 plus 5. That means A plus B is equal to B plus A. Which property is this? This property is commutativity. Right? This is commutativity. Right? Okay. Now 3 multiply, both are multiplication signs, like 3 multiply 4 multiply 2, like you multiplied 4 and 2 here first, and here you multiplied 3 and 4 first. Answer will be same. This property is associativity. Right? Okay. On multiplication, right? Here. And this property, A times B plus C is equal to A times B plus A times C. And this property is what? This is distributivity. Distributivity you can say, or you can say distributive property. Okay. And after that, we have question 4. Verify the distributive property. This is very important question if you are just learning these properties. So they will ask you guys to verify. How do you verify? For verification, we see whether LHS is equal to RHS. Okay, so I will solve LHS first. LHS means left hand side. What is left hand side? 7 times 5 plus 3. Okay, so 7 times 5 plus 3 is 8. What is 7 times 8? 56. Right? Now I will solve RHS. Right hand side. 7 times 5 plus 7 times 3. Right? What is 7 times 5? 35. What is 7 times 3? 21. And now I will add. It will be equal to 56. So left hand side is equal to right hand side. That means our property is verified. Okay, this is how we verify properties. We just do LHS and RHS. We calculate them and then we show that they are equal. This is how we verify. Okay. And now we will start our module 2. Module 2 is factors and multiples. Okay. What are factors? Factors means a number that is completely dividing a number without leaving the remainder. Without leaving the remainder. Okay. So like I have 24. If I ask you to write the factors of 24, then you will say 24. 1 divides 24. Right? 1 is factor of every number. Okay. 2 divides 24. 2 completely divides 24. Because if you divide 24 with 2, you will get 12. How many 2 fit into 24? You will say 12. So you will get 12. So 2 completely divides. So 2 is a factor. Okay. Does 3 completely divide 24? Yes. So 3 is also a factor. Then 4. 4 is also a factor. Does 5 divide? No. 5 doesn't completely divide 24. Okay. So we will say 5 is not a factor. And then 6. Right. 6 is a factor because 6 divides 24. And then 8 also divides 24. Right. And then 12. And then 24. So did you notice one thing, that 1 and the number itself is a factor. Okay, always. Here as well, if I see 36, so 1, 2, right? You do it yourself, pause the video, do it yourself, and then come and check it. Okay, 2, 3, 4, 6, 9, right? 12, and then 18, and then 36. These all are factors of 36. If I miss something, you can comment that in video. Okay, if it is right, then these are all the factors because they all completely divide 36. Okay, then similarly 48. This is a homework for you. You will comment your answer in comment section. Okay, after that, now we are supposed to write, they are asking us to write find the common factors of 18 and 24. Okay, I will write 18, I will write 24 here. Then I will write their factors. What are the factors of 18? 1, 2, 3, 4 and 5 are not, 6 and then 9 and then 18, right? Then 24, 1, 2, 3, 4, 6, 8, 12 and 24. Common means those numbers which divide both 18 and 24. Like 1 is common, 2 is common, 3 is common, right? And then 6 is common. Do we have any other common factor? No. So I will write here common factors. Okay. Common factors are 1, 2, 3, 6. Okay. These are common factors. Why are we writing common factors? Because after this we are going to learn highest common factor. HCF. You can say HCF, you can say GCD, greatest common divisor. Okay, which of these is the greatest? 6. So 6 is HCF. Okay, we write common factors, but I will tell you another method as well to find HCF, okay, or GCD. After this we have multiples. I hope you understood factors now. What are factors? Those numbers which completely divide a number are called factors. Okay. After this we have multiples. What are multiples? What is, have you heard about multiplication table? Write the multiplication table of 2. You will say 2, 2 twos are 2, 2 ones are 2, 2 twos are 4, 2 threes are 6, like 8, 10, right? If I say write multiplication table of 4, you will say 4, 8, 12, 16 and up to so on. These are multiples of 4. So these are nothing, the multiplication table. These are nothing but multiples. Okay. So if I ask you to write, a multiple of a number is obtained by multiplying it with any natural number. Definition looks complex, but it is not. So multiples are nothing but multiplication table. 7 ones are 7. 7 twos are 14. 7 threes are 21. 7 fours are 28. 7 fives are 35. These are multiples. Okay. 12, 24, 36, 48, 60. We wrote all the multiples of 5 multiples of 7 and 12. Now what is our next question? Our next question is find the common multiples of 4 and 6. You know, 4 and 6. You know, we can have infinite common multiples, because if I write multiplication table of 4, I will never stop if I keep writing. Okay, so we will just but they are saying that are less than 50. Okay, because we can write infinite multiples, but we need to write less than 50. So I will write 4, 8, 12, 16. Pause the video and try it yourself and then come again. Okay, 28, 32, 36 and 40. Right? Right? Okay, then 6. They are saying less than 50. 44, 48. I will also write till 48. Okay, so 6, 12, 18, 24, 30, 36, 42, 48. Now common multiples. 12 is common, right? Okay. And after that 24 is common, right? And then after that 36 is common, right? Okay. And then after that 48 is common, right? So I will write common. Common means which are in both. Common multiples 12, 24, 36, 48 up to so on. These are common multiples. And why did we do that? Because after this we are gonna learn LCM, least common multiple. Least common multiple. When we were finding HCF factors, then we were looking at highest common factor, highest, the biggest, largest. Here we are looking at least, smallest. Okay, so least means which is smallest of all, which is least of all, and that is 12. So what is LCM? LCM is 12. I'm going to tell you a short trick to find HCF and LCM by the same method only. Okay, we will do that later. Here, now we need to know what are prime numbers and what are composite numbers. And why are we learning that? Because now we need to learn prime factorization. We learned factors, what are factors, but now we will do prime factorization of a number. Okay, prime factorization means when we write the factors, only prime factors of a number. Okay, I will tell you what. So here, prime numbers. What are prime numbers? Any number which has only two factors, like 1 and itself. If I say 2, smallest prime number is 2. Okay, 1 is not a prime number. 2 has only two factors. What? 1 and 2. 3 has only two factors, 1 and 3. 1 and itself. 5 has only two, 1 and 5. 7 has only two, 1 and 7, right? 11 has only two, 1 and 11, right? So these are those numbers which have only two factors. No other number divides them completely, are known as prime numbers. Like if I say 13, 13 has only two numbers. No other number is dividing 13. So 13 is a prime number. So can you pause the video and tell me that write the numbers up to 50, prime numbers up to 50? Okay. And then what are composite numbers? Composite numbers are any other number that is not prime, like it that has other factors as well, is known as composite number, right? 4, 6, 8, 9, they are called any number with more than two factors. You can say that more than, because prime number has just two factors, 1 and itself. And composite, more than two factors, are known as composite numbers. And you need to know this thing that one is neither prime nor composite. Okay. After that, identify prime and composite numbers. 11 is prime, right? 15 has factors, like 15 is divisible by 3, 5, so it is a composite number because prime number has only two factors, 1 and itself, right? 23 is prime. 27 is divisible by 3 and 9, composite. 31 is prime. 42 is composite. All even numbers. What are even numbers and what are odd numbers? Even numbers are multiples of 2. Okay, which 2, 4, 6, 8, 10 up to so on. Okay, any number which can be divided in two equal parts are even numbers. Odd numbers, 1, 3, 5, 7, 9 up to so on, they are odd numbers, right? So if you see any even number, a number is ending with 2, 4, 6, 8, 0, they are always composite. Okay, so 42 is composite. 51, 51 is divisible by 3. You know divisibility rules. I will make a video on that as well, divisibility. Okay, 51 is a composite number, and 61, I think it is a prime. It is not divisible by any other number, so 61 is a prime number. Okay, so after that we have find all the prime numbers between 50 and 70. So 51, 52, I think it is 53 first, right? 54, 55, 56, 57 is divisible by 3, 58, 59, right? 61, 62, 63, 64, 65, 66, 67, right? And 68, 69 and 70 there. So these are four prime numbers between 50 and 70, right? Okay. Next we come to very important topic, prime factorization. How do we do prime factorization of any number? Do you know that 60 is divisible? Do you know factors? If I ask you to write factors, you will say 1, 2, 3, right? 6, 10. They are factors. 12, they are factors of 60. But I'm asking you to write the prime factors. Prime factors means so 2, 3, 5, like that. Okay. How will I do that? Prime factors. For prime factors, you need to know this thing, 60. I will write it as 60. I make this symbol and write 60 here. What always divide with only prime numbers 2, 3, 5, 7, 11 up to so on, and keep dividing with 2 until you can. Okay, so I will start with 2 because 60 is a even number, is an even number, so it is divisible with 2. So I will divide it with 2. What will I get? 2 3s are 6 and 0 30. Is 30 divisible by 2? You will say yes, 2. And then I will divide and I will get 15. Okay, whatever I get I will write here. I am dividing with 2. I 2 with 2 I will write here. Okay, now is 15 divisible by 2? Then you will say no, because it is an odd number now. So now I will go to next prime. What is next prime? 3. Is 15 divisible by 3? You will say yes. So 3 divided by 5. Now 5 is divisible by 5 only, and 1. So now what did we get? We got 2 times all these numbers which we got here. We will write here as a product 2 times 2 times 3 times 5. And when you will multiply them, 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. So this is called prime factorization of any number. When you write only prime factors, no matter how many times a prime factor is repeating, it doesn't matter at all. You just need to write prime factor. Okay, and this was factor. We can use this was division method. Okay, we can use factor tree as well. How? 60. Okay, 60 is 12 times 5. Now 5 is a prime. You will leave here. 12 is what? 4 times 3, right? And 4 is what? 2 times 2. So you got 2, 2, 3, 5. Okay, you can do with this method as well, but I prefer this method more. Okay, so you can use any method. Okay, now here 84. We will do 84 now. I will make this symbol, then I will write 84 here, right? I will start with 2. 2 4s are 8, 2 2s are 2. I divided 84 with 2. I got 42, right? Now 42 is again divisible by 2. So I divided and I got 21. Now is 21 divided by divisible by 2? No. So I will take another number 3. 21 is divisible by 3. I will get 7, and 7 is a prime, so I will have to divide it with 7 only. So I got 2 times 2 times 3 times 7 is equal to 84, and these are prime factors of 84. This is how we calculate prime factors. I hope you are getting it. If you are getting it, do like the video and share the video with your friends if you can. Okay, and now we come to next 120. I will write here 120. I will start with 2, 60, 2, 30. Are you getting it? I'm just dividing the numbers with 2 because I will keep dividing until I can with 2. Okay, now I will do with 3 because 15 is not divisible by 2. 5, 5, 1. So 2 times 2 times 2 times 3 times 5 is equal to 120. Okay, and this is a homework for you. 144. You will find the prime factors and write the prime factors in your comments. Okay, you can write, you can comment like this: 144 is equal to this, like that. Okay, now we have module 3, that is highest common factor. How do we find highest common factor? Okay, now they are saying find HCF of 36 and 48 using prime factorization method. Okay, how will I do it? I will tell you two methods. Okay, first I am doing first method only. Okay, look at it carefully. First I will find prime factors of 36. 2, 18, right? 2, 9, 3, 3, right? Then I will find prime factors of 48, 2, 24, 2, 12, 2, 6, 2, 3, 3, 1. Okay, this is what we can do because we are doing this for like quite a with some we have done it in few questions now. Okay, now here 36 is what? 2 times 2 times 3 times 3, right? And 48 is what? 2 times 2 times 2 times 2 times 3, right? Now they are saying highest common factor, product of common prime factors with lowest powers. Okay, this is common, this is common, okay, and 1 3 is common, right? Do we have any other common? No. So common are 2 times 2 times 3. So what is HCF? Highest common factor is 2 times 2 is 4 times 3, 12. So 12 is highest common factor. We did it with another method as well, if you remember, right? That I just wrote all the factors and then I found the highest common factor. And this is another method. This is second method, you can say. Now I will tell you third method. That is a short trick to find HCF and LCM together, and that I will tell you later only when we'll do LCM. Okay, so this is how we do. We find HCF when we have like 2 or 3 numbers. We just find all the common prime factors and then we write their product like that. Okay, we will do another example. Okay, so here 72 to 36 to 18 to 9. This I think now you guys can do this thing to find the prime factors, right? We just need to divide with prime numbers. And then after that I will do 108, 2, I will get 54, right? 2, 27, 3, because 27 is not divisible by 2 now, so 3. And this is what? 9, 3, 3, 3, 1, right? Now I will write 72. 2 times 2 times 2 times 3 times 3, right? And then we have 108. It is 2 times 2 times 3 times 3 times 3, right? Now what are common factors? 2, 2, 3, right? And 3, right? So I will just multiply all the common factors. 2 times 2 times 3 times 3. So 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36. This is highest common factor. Okay. Now likewise you can do this question. You will find 24 and 36 and 48 and then write all the common factors and then product. Okay, you can do it. This is your homework and then comment me in the comment section, right? Okay, this is a long method. Usually we don't prefer this method. I will tell you a short trick. We will do prime factorization method only, but still this long method as well we should know. Sometimes we need to apply this method when it is hard to find prime factorization. The methods, the numbers are bigger. Okay, here. So we have 120 and 180. How do we find HCF? We then follow division method. What is the division method? I will divide the bigger number with the smaller number, right? I will divide 180 by 120. How many 120 goes in 180? You will say 1, right? And you will write here and the remainder is 60. Okay, what is the next step now? We will keep dividing here 60 and this 120 will come here. Okay, and then 62s are 120. If we didn't get 0, we will keep dividing it. Okay, but now we got 0, we will stop here. So 60 is our HCF, highest common factor. Okay, I can verify as well. I will solve this question by prime factorization. 120 prime factorize 260, 230, 215, and then 3 5 and then 5 1, right? Okay, and then I will do prime factorization of 180 to 90 to here 45 and then with 3 and then with again with 3 and then with 5, right? Now I will write what is 120. Can I write here? 2 times 2, this is 3 times 5, right? And what is 180? 2 times 2 times 3 times 3 times 5. Common 2, 2, 3 and 5. 2 times 2 times 3 times 5, right? 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. So HCF is 60. Either you find out by this method or by division method, you will get same answer, but we should know division method as well. Okay. Now after that, module 4 is what? LCM, least common multiple. Okay, we will find the multiples. How? Here. So for LCM, I will tell you one method only, and then you need to work on this method again and again. Okay, so because this is very important and the simplest method. If you need to find, though we can find it with that method as well, that we find the prime factorization of 12 first and then 18 first and then do least common multiple thing. Okay, but instead of that, use this method. Now I'm going to introduce this method to find both HCF and LCM. Okay, so write 12 and 18 here. Now we will divide with 2 first because 2 is the least prime, right? Start with 2. 2, 6, divide 12 with 2, you will get 6. Divide 18 with 2, you will get 9, right? Now, if any of these numbers is divisible by 2, you will divide with 2 only. Because 6 is divisible by 2, but 9 is not. But even if one of the number is divisible, we will divide with 2 only. Now, what is 6 divided by 2? You will say 3. Is 9 divisible by 2? No. Then you will write 9 as it is. Now, is any of the number divided by 2 divisible by 2? No. But now, so we will come to another prime factor, that is 3, another prime number 3. Now divide with 3. Is 3 divisible by 3? 1. 9 divisible by 3 is 3. Now, if any of the number is divisible by 3, we will divide with 3 only. 1 will come as it is, and 3 is divisible by 3, divided by 3 is 1. So this is our answer. Here we will stop and write all these numbers. 2 times 2 times 3 times 3. 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36. This is LCM. Is it hard? Not at all. So we just need to practice, okay? If you will practice, you can master this. 15 and 25. I will again make this symbol and then 15 and 25. Is any of the number divisible by 2? No. So we will not divide with 2. Is any of the number divisible by 3? Yes. What? 15 is divisible by 3. 3 5s are 15. Is 25 divisible by 3? No. So you will write 25 as it is. Okay. Now 5 divides both of them. So 5 times 1. Okay. And then 5 times 5 is 25. Right. So now again with 5, 1 and 1. So we got LCM is what? 3 times 5 times 5. What is 3 times 5? 15. 15 times 5 is 75. And this is our answer, right? After that, LCM of 20, 30, 40. You will write this, make this symbol 20, 30, 40. Okay? I will draw straight lines, okay? 20, 30, 40. Okay? So 2, 10, 15, 20. Right? Again with 2 because 10 and 20 are divisible by 2. 2 5s are 10. 15 is not divisible. So I will write 15 as it is. 20 is divisible. So I will divide. Right? Again. 5 is not divisible by 2. 15 is not divisible by 2. But 10 is. So divide with 2. 5, 15 and 5. Right? And after that, 3. I will take 3 now. Why 3? Because 15 is divisible by 3. So 5 as it is, 3 5s are 15 and 5 as it is. Now I will divide with 5. 1, 1, 1. So what is LCM? 2 times 2 times 2 times 3 times 5. So 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, 24 times 5 is 120. So this is our answer. Okay. Now if you remember, I said to you that I will tell you a short trick to find HCF and LCM by the same method. So here is the short trick now. LCM you know how to find out. You just multiply all the numbers. But if I ask you find HCF of 12 and 18, I will write here HCF of 12 and 18. Then what will you do? Then what will you do? You will see here. Now check carefully. Is 2 dividing both these numbers 12 and 18? Yes. Yes. So you will take this 2. Okay. Now is 2 dividing both these numbers? No. So you will not take this 2. Now see, is 3 dividing both these numbers? Yes. So you will take this 3. Now you just take the circled numbers. 2 times 3. Answer is 6. Okay. For LCM, you take all these numbers. Everything. 2, 2, 3, 3. But for HCF, you only take those numbers, those prime numbers which divide both of these numbers or all of these numbers. Like let's see here 15 and 25. Okay. If you see here 15 and 25, check here. Is 3 divide both of these number? No. 3 doesn't divide 25. So you will not take 3. Is 5 divide both of these number? Yes. So you will take 5. And this 5 you will not take because it doesn't divide 1. So what is HCF of 15 and 25? Only 5. Isn't it easy? It's very simple. This is a short trick to find HCF and LCM by same method only. Okay. Here HCF of 20, 30, 40. Is this 2 dividing all these numbers? Yes. So take this 2. Is this 2 dividing all these numbers? No, because 2 is not dividing 15. Is this 2 dividing all these numbers? No, because 2 is not dividing these 2. Is 3 dividing all these numbers? No, 3 is not dividing these 2. Is 5 dividing all these numbers? Yes, 5 is dividing this. So you will take circle numbers 2 times 5 and this 10. So what is HCF? 10. It's very easy to find HCF and LCM by the same method only, just this prime factorization method. Okay. And now very important thing that is being asked in competitive exams, Olympiad questions. You need to know this. What is the relationship between HCF and LCM? Suppose you have two numbers and you are finding HCF and LCM. Then this is a relationship between them. That HCF, you multiply HCF and LCM both. And then you multiply first number and second number, both numbers. Okay. Now, you know what? Now we have four things here. One, two, three, four. Out of these four things, they will tell you three. And then they will ask you guys to find fourth. How? They are saying HCF of two numbers is 6. And they are telling us LCM is 72. Right? They are saying HCF is 6. LCM is 72. One number is 18. They are saying find the second number. Out of these four things, they are giving you 3. So we just need to substitute the value in this formula. What is HCF? 6 times LCM 72. First number 18. We need to find second number. Okay. Because we need whatever we need to find that is unknown. Whatever is unknown will be left alone. We will divide both sides with 18. Right? It will cancel out. And now can you solve it? 6 ones are 6, 6 threes are 18. This is how we solve, right? 3 ones are 3, 3 twos are 6, 1, 24. So second number is what? 24. This is our answer. that second number is 24, right? After that, we know the formula. They are saying HCF is 12 product of numbers. Now they are saying product of numbers. First number times second number is 3, 4, 5, 6. Okay, and one number is 96. They are saying find the other number, find the second number. Okay, so so that means we don't need HCF here. First number times second number is what? 3, 4, 5, 6, right? And first number is 96. So 96 times second number is 3, 4, 5, 6. What is second number now? 3, 4, 5, 6 divisible by 96. We will simplify this, right? Both are divisible by 2. 2 ones are 2, 1, 2 sevens are 14, 2 twos are 4, 1, 2 eights are 16, right? And then again with 2, 2 eights are 16, 1, 6, 4, right? And then with 4 it is divisible, 4 6 are 24, 4 twos are 8, 1, 6, and this 36. So what is second number? Second number is 36. 36 and 96 and HCF is 12, right? So it was not difficult at all. So this was our package on number scales where we learned about all this stuff like what are natural numbers. We learned from the very basic, and then we learned HCF LCM, how to find them, and then their relationship. Okay, so if you like this, do subscribe to my channel, and if you want to watch Olympiad questions, you will find many videos on Olympiad questions, short tricks and concepts on my channel. Please visit and give your reviews. Thank you for watching. Bye bye.